One, 2, 3. So summary, it changed itself to try and use the camera as a microphone. So I've just fixed that for you as well. So, but yeah, you guys did everything right. It just set itself as a microphone. You've also got these microphones on here as well. I'll pick up with you.
Right. Okay. Thank you.
Is there anything else you need? Or?
I think this one.
No, perfect. That's all right. Take care.
I hope all of you can hear us now.
Yes.
Thank you so much.
Yes.
Good morning, ladies and gentlemen, distinguished professors, respected keynote speakers, honored guests, researchers, delegates join us here at the University of Essex, as well as participants attending online from across the world. A very warm welcome to each one of you. It's my great pleasure to welcome you to the International Conference on Networks, Computing Systems, and Data Analytics, organized in hybrid mode at the University of Essex. Today's conference brings together researchers, academics, industry professionals, and students to exchange ideas, present innovative research, and foster collaborations in the rapidly evolving fields of networks, computing systems, and data analytics. Whether you are joining us physically or virtually, we sincerely appreciate your presence. On behalf of the organizing committee, I extend heartfelt thanks to our keynote speakers, authors, reviewers, session chairs, sponsors, and participants. We hope today's discussions inspire new collaborations and exciting research opportunities. Once again, welcome to the International Conference on Networks, Computing Systems, and Data Analytics 2026. To officially commence today's program, it is my honor to invite the organizing chair of Icncda 2026, Dr. Vishal from the University of Essex, to deliver the welcome address.
Hello, everyone. I hope all of you can hear me fine. Yeah. So, thank you for being here and being part of this conference. We have, sorry for the technical delay. There was some technical glitch. We were able to finally resolve it, and now we are here to officially announce this conference. As you can see, many of us have joined us in person, but many of us are also present in online and have joined this conference from all over the world. This conference, the International Conference on Networks, Computing Systems, and Data Analytics, is the first edition of this series and is aimed at becoming a premier global forum that brings together researchers, academicians, industry professionals, and practitioners to exchange knowledge, ideas, and innovations across the domains of networking, computing, and data-driven technologies. Our aim is to foster collaboration between computing and data science to address emerging challenges in building intelligent, secure, and high-performance systems. The conference provides a platform for presenting cutting-edge research, discussing real-world applications, and exploring the future of connected computational and analytical ecosystems. The primary goal of this international conference is to gather quality application-based research work for betterment of society and human welfare as a whole. The major benefit of the conference proceedings is that it will gather latest quality research of researchers working on the current areas of communications. Readers can have the glimpse of latest research works in one book. The other targets of international conference, such as this, are as follows, which are: the first one is firstly to promote the exchange of innovative scientific information between researchers, developers, engineers, students, and practitioners. Secondly, to promote the transformation of fundamental research into institutional and industrialized research and to convert applied exploration into real-time applications. Overall, the international conference is to lay a platform for researchers, engineers, academicians, as well as industrial professionals from all over the world to present their research and development activities on various topics of engineering and technology. An important thing to note about this edition of Icncda is a panel comprised of high-profile national and international researchers who have contributed to the conference with more than 300 papers being received from around the globe. This conference has allowed recently completed PhD holders as well as researchers in different domains to explore the new areas coming out of their completed research work by publishing a novel work stating the future and applicability of their research work. The Icncda 2026 is focused on to spread the importance of quality research in the region where it is going to be organized so that academicians understand the importance of research in relation with the education they are imparting to their respective students. Finally, the goal of Icncda 2026 is to provide opportunities for academics to receive informal, in-depth feedback through discussions and to enable them to establish contact with professionals in their countries and institutions, and also to encourage regional and international communication and collaboration. With this end, I heartily welcome all of you to present your research work at this conference. Those who are present here to present the work in person, they are most welcome at the University of Essex. Those who will be presenting the work in online mode, they are also most welcome to present their work, and we hope to see you in sometime soon in our future editions of this conference in the UK or in Europe. Thank you so much.
Thank you very much, Dr. For your inspiring words and leadership in bringing together this international gathering of scholars and researchers. We now move to the launch of the Icncda 2026 conference proceedings, followed by the felicitation ceremony. May I request our distinguished dignitaries to kindly come forward for the proceedings launch. Organizing Chair, Dr. Bishop, the University of Essex, UK. Dr. Rahmat, University of Essex. Member Advisory Committee and Public Chairs, Dr. Rama Pula, University of Essex, and Member Advisory Committee, Dr. Rab Nagwa.
What we'll be doing is we are just going to launch the proceedings. Can anyone please take pictures of him? So what will be doing is okay. Thank you. Thank you.
Okay. Publication chairs. Dr. Ratma Pula, University of Essex, UK. Can you come again?
Can you please take some pictures, anyone, please? Thank you so much.
Member Advisory Committee, Dr. Rawa. Oh, Dr. Badil, please.
Thank you so much. Thank you so much. Thank you so much.
Congratulations to all contributors whose work made this series possible. And with this, we now conclude the inaugural session, and we shall now break for networking tea. And kindly return by 10:20 as we begin our keynote session promptly. Thank you.
We'll take a break and we'll reconvene in 20 minutes.
So you guys can have some tea, coffee, whatever you like. So we'll be coming back and starting again in 20 minutes, right? So 10:05. We're starting from the keynote section.
Innovation Center.
Distinguished delegates, a very warm welcome once again to our respected professors, researchers, academicians, industry professionals, session chairs, authors, and participants joining us from different parts of the world for the International Conference on Networks, Computing Systems, and Data Analytics, Icncda 2026, organized by the University of Essex, Colchester, England, United Kingdom. The inaugural proceedings of the conference have concluded successfully, marking the official commencement of Icncda 2026. We now move forward to the academic program of the conference, which brings together distinguished keynote speakers and peer-reviewed technical presentations spanning contemporary advances in networking, computing systems, artificial intelligence, cybersecurity, data analytics, and emerging technologies. We shall commence this session with a keynote address. It is my privilege to introduce our distinguished keynote speaker, Professor Dhaval Kumar Thakur, Professor of Artificial Intelligence and Internet of Things at the University of Hull, United Kingdom. Professor Thakur is an internationally recognized academic whose research spans artificial intelligence, Internet of Things, knowledge engineering, semantic technologies, intelligent systems, and digital transformation. His work has contributed significantly to interdisciplinary research and the application of intelligent technologies across healthcare, smart environments, and data-driven decision-making. His expertise reflects the multidisciplinary vision of Icncda 2026, making it a privilege to welcome him to today's conference. Professor, we warmly welcome you.
Thank you, Tanvi. Thank you for that kind introduction. Can everybody hear me? The room, the virtual room and the physical room?
Yes, sir, it's completely audible.
All right, thank you. I'll just share my screen. I believe you can see the presentation on your screens. Tanvi, if you can confirm it for me.
Yes, sir, it's working.
The main slide is visible, yeah? Okay.
Yes, sir, yes, sir.
Just over here. If it's okay, I can get started. Just move this. No. Okay. Hi, everyone. Thank you for that kind introduction, Tanvi. I'm Professor Dhaval Thakur. I'm the head of Center for Responsible AI here at the University of Hull. Sorry, I can't be there in person due to personal reasons, but it's my pleasure to deliver this keynote address. And I'm very thankful to organizers for inviting me. So the topic I'm going to cover is about the next frontier in responsible AI, and try to make a case that we need to think more about different aspects of responsible AI, such as explainability and safety and fairness at the edge, and why it needs to be native to edge AI. So this is my outline. I would be talking about research in responsible and edge AI, some of the work we have done, so the state-of-the-art work, including techniques and approaches. And then I'll be, as I said, trying to make a case why that needs to move to edge in the sense of edge devices as well. But that's extremely challenging. And what are the state-of-the-art and open challenges there? So this is my broad sort of outline. So when it comes to our research, as I said, I lead a research on a center on responsible AI at Hull. We focus on this when we talk about responsible AI, this triangle. We look at explainability and different techniques around statistical and neurosymbolic techniques for achieving human level explainability, that holy grail. Then we focus on the trustworthy aspects of AI, where safety and reliability is one of the focus, but we also look at assurance frameworks as well. Some of this I'm going to cover in my slides. And then we also look at the third dimension of responsible AI as we see it, which is fairness, which is making AI equitable. And this is where we work on looking at bias in the algorithms, looking at individual and group fairness level. So that's what we try to do. We are a fairly large center. This image is a bit outdated. We are about 10 to 12 academics and 15 research students and research assistants and staff. These are some of the, again, this is a slightly older slide. These are some of our projects and funders from EPS. We mainly work on EPSRC and Innovate UK funding, but there are other funders as well who have funded our work, and there are a number of industry partners as well who has worked with us on this different project or directly funded our research. So what I want to start with is talk about one of the projects or a couple of the projects we have done and use them as an examples later on when I'm trying to make some arguments and case for responsible AI at the edge. So the first one, we worked on an Innovate UK project, which is developing a smart AI speaker for adult social care with a company called Connexin, which is a smart city, smart tech company in the UK. And this is a burning issue at the moment and has been for a while in the United Kingdom when it comes to adult social care. Our recent new Prime Minister has been talking about this a lot. The focus on this project was part of that, number of problems which exist in adult social care. The documentation burden is one of the key challenges there. In UK and in this context, we are only talking about domiciliary care, which is residents being taken care of in their own home, where care workers go and help them with different tasks. While doing that, or after their visit, they have to keep a record keeping, which goes as part of the care record of that particular resident. So things like medications which were given, the mood of the resident, the activities they were helped with, or the resident might have carried out during past, from the past visit to now. And obviously there is they are given a very limited time to do this. And in UK, there are many studies which shows that there is a huge burden on social workers to document these things, and the technology hasn't penetrated in terms of how that could be used to alleviate some of these challenges. And there are reports around higher work-related burnout scores for care worker staffs. So this is an interesting but very important challenge where we thought that AI could help. So in this project, we worked on building this smart AI speaker, which has two parts: speaker functionality, which is a voice control for everything. So rather than them typing things, they could ask a question about the resident from their care record, or they can update the care record based on the activities they have helped them with, or medications they've given, and so on. So everything to be done through the voice. There is a smartness part, obviously speech to text ASR model, but also understanding the questions and finding the information and updating the information, bit around semantic indexing and retrieval. And a lot of this is, we are not converted this into fully edge AI systems because a lot of bulk of work is still done on the cloud. And this is how it works. So you have like Alexa, you have a wake up word, such as activate, and then you choose a care record section. So there's a care record ID. Is it about mobility? Is it about personal hygiene? Is it about medication? And then you could either record an entry to the care record, or you can retrieve information by asking question, for example, what is a preference in so and so, and you could sign off. And there are other keywords you could use as well. And there is a nice integration with calendar as well for reminders for important tasks and so on. So this is an example of AI system, and I've used that example to give to make a bigger point, which is these AI systems, as it gets developed, they are obviously a software. It is a system. It has components, and any software which is used in regulated domains, and adult social care is a regulated domain. I forgot to mention that our specialty and our expertise is working on regulated domains from defense, healthcare, energy security, and so on. So it becomes paramount that you are able to provide assurance of this AI system and its components. And this is the work we have done. One of my PhD students working on this, where we have developing this AI assurance framework that could be applied to assure AI system or its components similar to the one I presented. So the wheel you see is, I would say, still work in progress, has come about by reviewing 100 plus, academic literature and industry practices, including government guidelines. And there is a citation at the bottom of this slide. And what you see is there are different areas of assurance that you have to look after when you are developing a complex system in a regulated sector like this. And that what the table around are showing is that this sort of theoretical framework can help you for identifying what are the key points and what are the risks and impact of this sort of system. So, for example, for this AI speaker, one of the key points is over-the-air and speech exposure. So sensitive information could be overheard, risk of data disclosure in public areas. So this is if you have a theoretical framework which gives you kind of a checklist, then you could identify this sort of key points and risks and impact, so that you can provide more to the next stage, which is moving towards assurance. Again, this is that is still a heavily theoretical framework. You need to operationalize it in some sort of technical system, and that could be something like this. This is a goal structure notation, which is used for safety assurance to structure arguments about your top level claim. For example, your top level claim, as it says in this diagram, is deploying the smart speaker does not pose unacceptable risk, because that's what you are trying to prove. That's your AI assurance goal. Then that could be devised into a number of different areas. So you could have, for example, taking this speaker example, you could have retrieval risk, you could have speech recognition risk, you could have robustness risk, you have explainability risk, and many other risks which could be, and I'm not going to go into a lot of detail of that. But then you can go and use this theoretical framework as a guideline to decompose into what are the source of those risks. So, for example, if it's a retrieval, the risk can come from getting the category wrong. So, when you are starting out, as you've seen in that example, if you get the category wrong, so rather than medication, let's say, if the system gets it wrong in terms of speech to text and it thinks it's about mobility, then it's just pointless, isn't it? It doesn't work, whether it's about insertion of record or retrieval of the record. So you need to identify what are your, how would you prove, what sort of evidence you would provide to show that risk is manageable. So that's where, for example, you need to, in this case, we say that we have to have 100% category ID accuracy, but also if you get the resident ID wrong, then it's just pointless. It makes things even worse. So that's why you have 100% resident ID accuracy. So you could see that a theoretical framework now converted into a traditional safety notation. And then this is how you could sort of assure your AI systems as you assure software. so I want to sort of, the other projects or other work we have done, which I'm going to talk about before I come to the central point of the talk, is done in the context of this project called National Edge AI Hub, which is one of the 9 hubs which were funded in 2024 as part of £100 million investment from EPSRC, which is a research council in the UK, funds a lot of research into science and engineering, including AI and quantum. So this is led by Newcastle with many other partners, which has been expanded since then, including University of us being academic partner as well, and we have a number of industry partners that support some of the work we do as well. So I just wanted to talk a little bit more about what this hub is about. You could have I think one of the arguments we are making in this hub through this work is that AGI is going to be the choice of architecture for many of the mission critical systems or safety critical systems such as healthcare, defense, energy security, and so on, where latency is a challenge, privacy and security is a challenge, and so on. And when that's the infrastructure of the choice, where you want to do a lot of AI compute and some of the training in situ as well through Edge AI, then they would be susceptible to cyber attacks as more and more Edge AI devices are deployed and more compute is done on situ. So the mission of the hub is to protect the quality of data and quality of learning associated with AI algorithms, when they are subjected to cyber disturbances in the edge computing environments. And that's the key focus of the hub. And we've been contributing with some of the work we have been doing in this area. So one of the work which we have done is called hybrid VFO. Again, as a community, we know that edge environments and federated learning are a great match because of the client and server architecture it provides. In this work, we have developed a hybrid vertical federated learning framework for safeguarding privacy for Edge AI in the context of healthcare. Again, I'm not going to go in a lot of details because there is a citation there. I'll share my slides later on. The organizations, the way hybrid vertical federated learning works is, you would have a certain client would have certain modality for the same patients, for example, in this case, skin cancer detection, while other client would have more numerical tabular data, for example, patient medical records. So it's about the same patients, images in one client, the medical records, numerical tabular records on the other client. And the way hybrid FL works is, is each client produces modality invariant, so image invariant features and image specific features, for example, modality specific features. Then it is fused and aligned on the server using a transformer. And through doing this and showing this, we were able to show that it creates a stronger privacy preserving model for diagnosis. So even while keeping this two records separately and doing this sort of fusion and alignment, we are still able to achieve near centralized accuracy, as if those things were on one device, on one system, while giving better protection in terms of privacy. Again, there is a citation there. The other work we have done is around skewness guided pruning of multimodal swing transformers. So again, when you talk about edge devices, one of the main thing you have to do is you have to reduce the model size, because your compute is limited, your resources are limited, and then you have other constraints which we'll talk about. So pruning is one way of doing this. Is the process of trimming a model by removing unnecessary parts, for example, weights, neurons, and so on. And there are a number of ways this is done. In literature, either you do redundancy pruning, just look at the redundancy, or you can look at structure importance. So you would prune, based on importance scores, or you can do semantic pruning where you can use explainability to guide pruning. But this is computationally heavy and complex. But what we have done is in this work is swing transformers, which are already considered more efficient than standard vision transformers because it looks the way it looks at the image patches. It is already optimized that way. What we were able to do is that we looked at the skewness of swing transformers activations to identify and physically remove less selective attention heads and MLP channels. And that showed that this could reduce the model size, and while the classification performance would be intact, still intact. Again, there is a citations on this work. So I just wanted to give you some idea of some of the work we're doing on AGI space, and there is more, but due to limitation of time, I wouldn't be able to cover more in that direction. Because what I want to do is for the next part to talk about more about responsible AI and focus on explainability and fairness, not so much on safety for this talk. And just to bring everybody on the same page, some of this might be familiar with you already, but explainability is about explaining the decision result of a model, and this is a typical taxonomy of how XAI techniques are divided into different ways. You could just have models which are interesting and have inherent explainability, such as decision tree models and so on. Or you could have a post hoc after training explainability, where what you're trying to do is after the training is done, you are explaining at the end, based on individual predictions, or you are explaining the whole behavior of a global model. And again, there would be further categories in terms of something being model specific. So there are certain techniques which work with certain type of models. For example, GradCam working with CNN type of models, while you could have model agnostic techniques such as LIME, which would work with any of the black box models or most of the black box models, and something I'm going to cover in the next slide. So again, the LIME is local interpretable model agnostic explanation. That's what it stands for. So focus is on local explainability rather than the global explainability, specifically when it comes to LIME. What it does is supports explainability by showing the focus area of the model. So that might be, where the model focused. For example, it might be a particular region of the image. Let's say if you're looking at a tumor, then it can show where it focused, and if it works well, it would be the tumor area it has focused on while classifying something malignant, for example. Or it could be, in this particular case, input data, such as symptoms in this case, that contributed to the model decision of flu. So what are the features, symptoms it has focused on, while providing the classification. So that's what then becomes explanation out of LIME. And without going into too much technical detail, the way LIME works is it's a local explainability. So what you're doing is you're picking an instance. So you could say, this this patient was identified as having malignant tumor using this images and scans. What you can do is you can create perturbations, which is the variations of that instance or image. So you can mask some pixels and create variations of that image, and then you feed that into A black box model, now black box model will give you, based on this changed perturbed image, will give you a prediction. And then you have number of perturbations on one side, number of predictions on the other side. And then what you do is you fit a surrogate model. So you give that to a linear regression or small decision tree. And because they are inherently interpretable, the surrogates would have, the surrogate model would have coefficients or rules which can show which features influence the black box model's decision locally. And that's how you could, even with the black box model, using a surrogate model, you can achieve explainability. And that's how LIME basically works. You also have other techniques in explainability in the literature and in practice. This is called neurosymbolic AI or NESI AI for explainability, but also for accuracy and precision and so on. What you're trying to do is you're trying to combine statistical AI, such as machine learning, with the strength of symbolic AI, which is human-like knowledge and reasoning. And there is a strong role of something called knowledge graphs, which is used for knowledge representation, but in a modern sense, scalable knowledge representation. Without going into too much detail, if you're not familiar with the knowledge graphs, it's a kind of a knowledge model. You have a number of interlinked concepts, entities, relationships, and events, and basically they are used to use with the deep learning models, statistical models, to provide you that underpinning you need, the grounding you need, because generally when you build a knowledge graph or when you use a knowledge graph in an organization, you are trying to keep it very clean, very updated, and very pure, because that could be used as a ground truth in terms of building accuracy or in increasing the accuracy and explainability in statistical systems such as machine learning techniques. And there are many knowledge graphs which exist, so you generally don't start from the scratch. Something called DBpedia, Yago, but obviously Google also uses a knowledge graph for its search, and this is what you see in the info boxes when you search for an actor or a politician or so on. So with this neurosymbolic AI for accuracy and building better systems, or for explainability, you can integrate the knowledge graph in your deep learning and machine learning systems very differently. You could have, and it will depend in terms of how tightly they are coupled. In the simplest being the shallow infusion, where they are in a pipeline where one gets used after the other, or vice versa, or in some combination of them, or the knowledge graph gets used in the building of the models itself, and that would be semi-deep to deep infusion. And how that can help. So this is work which is done by colleagues in the United States. So just giving an example of a shallow infusion. So here there is a tweet on the left-hand side, and this could be used for AI fakes as well, where there was a tweet from somebody about Magic Johnson, who is a player. I think he's a basketball player, big basketball player in the United States. And he was shown to give a blood donation in this tweet. And this is a system which is designed for multimodal fact verification by these colleagues, where the deep learning system is used for visual aspects. So, for example, this is identifying and matching this person to be Magic Johnson. The activity recognition, which is this looks like donation of the blood, and this itself looks like a hospital. But then if you combine that with the knowledge graph, that Magic Johnson is a player, the facts about him, but also the fact that he's contracted HIV at some point in his life. And you would have facts about the blood donation. In this context, it's United States, where American Red Cross does not accept blood donation from HIV positive donors because of the risk involved, according to them. And that's if you combine those two facts, you could use that for fact verification that this could be classified as a fake news. So that gives you some idea of some of the techniques which exist, and we also work on this technique, statistical, such as LIME, but also neurosymbolic techniques as well. And when we talk about bringing these techniques, and so far I've spoken about explainability. I'll talk a little bit about fairness at the end as well. Then what are the specific challenges when you bring that to the resource constrained edge devices? And one of the takeaway message I want to give as part of this talk, and this is something we believe in, we try to work on this as well. Very initial stage is, when we're talking about edge AI, moving AI to the edge, the models to the edge for inference, but some of that for training. The argument we are making is that explainability must move to the edge as well. So we cannot have edge decisions, but cloud explanations. And again, the context we are coming from is from regulated domains. So there might be, again, exceptions and cases where this is okay. But everything I'm going to talk about is in that particular the context. Because latency, why I'm saying this is because latency matters for safety, and accountability must be immediate. So if you take that example of a smart speaker, AI speaker I talked about, for the adult social care, when the edge device detects a safeguarding concern or urgent health issue, the system must explain its decisions instantly to the family or the person who is helping the residents, the care worker. If the explanation depends on the cloud, connectivity issues or network delays mean care worker receive no justification in the moment when it matters the most. So safety critical decisions require real-time local explanation so that accountability is immediate and action can be taken. But it is extremely hard. This is an area of development, active research development. So if you are a researcher, PhD researcher starting out, this is something is a worthwhile exploration, because there are many open challenges, and I'll just try to qualify why I think this is why we think and why people think this is a extremely hard problem, because we haven't solved XAI fully for non-resource constrained devices such as cloud. Doing that on the edge devices is even more hard. You have system constraints, you have performance and energy constraints, so that some of the techniques, for example, LIME, which I talked about, that is sharp as well, is not possible to use out of the box. You have communication and bandwidth limits, so you have to generate explanations locally, cannot send large data to cloud. You have problem with scale and device diversity, where you have, like IoT devices, edge devices have heterogeneity problem. So your explanations has to work across different hardware. There are physical and environmental constraints as well. Obviously, in physical environment, not in nice data centers. There are more challenges, and that puts more onus on having robust techniques. Then you have data and model constraints. So you have privacy and security risks. You have, you don't want to lose leaked data. You have more a problem with models changing really fast. You have multi-model and complex data, so you need to focus on fusion-friendly XAI. Then you have more human and operational challenges as well in terms of usability. I talked about, if you are showing this to residents, the care workers in residents' home. Explanation must be fast, simple, and actionable for sometimes non-technical users as well. And then, the thing I talked about, assurance, we are not sorted that even for, non-edge devices, for cloud systems. So this is even more harder to have auditable XCI on limited edge devices. Then you have network challenges, limited or no network connectivity, and that brings a lot of other challenges as well. And there are, I'm not going to talk about this into detail and skip this slide, but I've just kept this here because we looked at the literature, and there are ways people have been. This is not, even though to us it looked like this is, not a lot of work there. There is actually a lot of work addressing each of these areas. But I think obviously the challenge becomes then, how do you sort of do all of this for all of these challenges, which would be the case when you are trying to deploy systems in the real world. So what I'll do is I'll just talk about some of the state-of-the-art work we have seen, and when we did the literature review on just one aspect, which is system constraints. So, for example, performance and energy constraints. Obviously, you're looking at, reducing the size of the model. I talked about pruning before, but there is quantization as well. There's distillation, and then you'll be focusing on the right hardware for the right challenge, or right problem. So all that does help. But then, when you're trying to reduce the size of the model, does it have impact on the explainability? And this is still early days. There is some work on this to check whether when you're doing quantization, does it lead to less sharp explanations, which might be mirrored in the model's performance loss. And there is some evidence that happens. So this is a message that you need to do careful selection if you want to have a good explanation fidelity. Also, there is some work in terms of XCI being one of the guiding principles in terms of how you do quantization. So what are the important parts of the model at higher precision, that importance is measured by XCI methods. When you talk about LIME and SHARP, which are extremely popular for cloud-based AI systems, there is some work that when you are doing this, when you do the perturbations, there might be impact on final explanation quality, despite that being of smaller magnitude. So this is everybody, people have started looking at this as a serious and challenging problem. There is also a newer trend in terms of not only compressing the models, but compressing the explanations as well, making the explanation outputs cheaper to compute, store, or transmit in edge federated settings, because again, edge and federated goes hand in hand. And I think in not so in distant future, we can see that people are focusing quite a lot in terms of edge native and explainable AI. And then there might be more work in resource-aware XAI techniques and possibly new standards and libraries for this sort of devices. And this is the message for researchers and practitioners, that we have to be mindful about explanation fidelity. It's not only about model compression. The same thing applies to pruning as it applies to quantization as well. There are some emerging works to prune explanation critical pathways so that the model compresses without losing interpretability. And there are causal explainability techniques which people have been working on this. But again, it's still an open problem in terms of bringing all these constraints together into one unified optimization problem. So last few minutes, I want to devote that to fairness before I conclude my talk. I hope I haven't lost you too much, is about fairness. So we talked about explainability. The second aspect is fairness. And obviously fairness is about fairness of a model. When you're trying to do that, what you're trying to do is you're trying to check that the performance and outputs are the same or similar for different groups or different individuals with similar characteristics. So you're not unfair to one group over other group. And this is what group fairness is called. But also, if you do this for individual fairness, you can do this with individual fairness as well. And there are various techniques to various metrics to do this, measure this. So you have demographic, all the way from demographic parity, where you're focusing on making sure that the repository results are same across all subgroups, or all the way to predictive rate parity, which is focusing on true positive is the same for all groups. So there are different ways to look at that, including equalized odds and equal opportunity. And as I was making an argument about local, more local AI models on edge devices and local explanation, the argument is not that straightforward when it comes to fairness. So where does the fairness monitoring and measurement stay? And one argument is that it should be accessed centrally across populations and contexts. And if you take the example of adult social use case and the speakers I've talked about, each edge device only sees one home, one client, and one context. So it cannot detect systematic biases, which you don't want to have as part of your global model, which you then distribute to your clients. So fairness must be analyzed across many homes and many users at the central level, and only then can be improved. And that's where you could keep improving that back to the edge devices. Having said that, the monitoring might be centralized, while the enforcement and constraint may need to be distributed, some local, some central. And just coming to the last few slides now, I'm aware of the time. So again, there are similar sort of challenges, resource constraint, connectivity problems, data privacy, heterogeneity, and scale. That doesn't change because that's the device's challenges. But it means different for fairness than it means for explainability with some similarity. For example, you still want lightweight models, you still want to compress the model as well. But then what happens is these techniques are normally optimized to preserve overall accuracy. But you might have a really good overall accuracy, but it can conceal subgroup harm, so that there might be unfairness to some subgroups in doing this. So that could lose accuracy on hard minority group of data, and this is what we call compression fairness trade-off. The danger is that compression may preserve overall accuracy while reducing the performance of particular subgroups. Because globally unimportant does not mean unimportant for every subgroup, because that's how it would be working. So this is another interesting research problem. To build a fairness preserving quantization techniques, there is a very little work in this area. So that from resource constraints, if you go to other constraint, which is internet connectivity, again, a federated learning setup, you're talking about, again, edge devices. So even before we discuss, before we discuss the, model behavior, we face even a bigger, more fundamental question: whose data reaches to the learning process first? Because that's the core of, how the model works and how it functions. And as you know, that it could be operating in a volatile environment. You might be using federated learning. What you get is a participation bias. So model effectively learns from users with expensive connections, which are constantly connected, who join federated rounds regularly, but they might not be representative of the full population. You also get a reach node bias, so it ignores users with spotty connections. You have, people who have rural or lower income, households, the server might receive updates from reliable devices, but rarely sees updates from poorly connected ones. And this could lead to, problem with performance fairness as well. So there is some emerging work around fairness over client sampling, so that low connectivity or rarely seen clients are prioritized or reweighted. And there is also work around asynchronous federated learning techniques, which also integrate the stale or delayed update so that everybody's taken into account. But this is still not panacea. There are still open challenges and problem with this, because it's always difficult to include if the client is going to stay offline, right? So because that might still be the case. Also forcing the participation from slow offline devices could delay the global updates, which is not always suitable for time critical models, and you could have versioning issues and so on. And the convergence instability will still remain a major issue as well. And this is again a quite acute challenge, which is people have started looking at and tackling now. So that's my final slide, slightly over the time. Sorry about that. The take-home message here is, this is a very, very early stage field, although there is a lot of work out there, but the kind of challenges it presents, it's still early days. Especially you combine federated learning with edge devices, it brings an extra layer of complexity and I would say opportunity as well. In my talk, I only covered some challenges. I covered fairness and explainability separately. In real world, in ideal world, you wouldn't want to do that. You wouldn't do that. And we didn't even think about the safety. I had them in isolation, as I said, the challenges as well and how you deal with them. But again, you have to handle most of these challenges together, connectivity issues, resource constraints, and sometimes you improve one, you make other thing worse, and so on. So the final message I would give is the challenge is no longer simply to make AI models small enough for the edge. It is to make the entire decision and assurance pipeline, including explanations, fairness monitoring, privacy protections, and safety evidence, work within the edge constraint. So that's an extremely hard, challenging, but really interesting problem. Thank you for that.
Thank you so much, Professor, for that insightful and thought-provoking keynote address. We sincerely appreciate your valuable contribution and thank you for sharing your expertise and research perspectives with the global academic community gathered here today. Participants, kindly note that there will not be a live question and answer session following the keynote presentation. Those wishing to communicate with the speaker may kindly forward their queries through the organizing committee at support@icncda.co.uk or icncda.congress@gmail.com. I repeat, those wishing to communicate with the speaker may kindly forward their queries through the organizing committee at support@icncda.co.uk or icncda.congress@gmail.com. The conference now proceeds to its technical paper presentation sessions, which constitute one of the principal academic components of Icncda 2026. These sessions provide an international platform for researchers to present peer-reviewed scholarly contributions, exchange scientific ideas, and engage in constructive academic discussion across the domains of networking, computing systems, artificial intelligence, data analytics, cybersecurity, and emerging digital technologies. The organizing committee extends its appreciation to every author whose work has been accepted for presentation today. Each accepted paper represents a valuable scholarly contribution and reflects the rigorous standards maintained throughout the review and selection process. We also acknowledge the continued support of our distinguished session chairs, whose expertise and commitment are instrumental in ensuring the smooth conduct of today's technical sessions. The technical program will now be conducted through parallel presentation sessions. Participants will shortly receive invitations directing them to their respective session rooms. Upon receiving the invitation, kindly accept it to be redirected automatically to your designated breakout room. To facilitate efficient coordination, I request all participants to rename their Zoom profiles using the following format. For presenting authors, the format is to be session number hyphen paper ID. And for the session chairs, the format is to be name hyphen session number. I repeat, all participants are requested to rename their Zoom profile using the format session number hyphen paper ID for presenting authors. And for session chairs, the format is name hyphen session number. The presentation schedule has been circulated to all the participants. Authors are kindly requested to ensure that the presentation slides are ready prior to the announcement of their respective paper IDs. Presenters are requested to adhere strictly to the allotted presentation time in order to ensure the smooth conduct of the technical program and to provide equitable presentation opportunities for all the authors. The session chairs will moderate the proceedings, facilitate the discussions, and oversee the evaluation process within their respective sessions. The conference will reconvene following the completion of the technical sessions for the keynote address and the Icncda 2026 awards ceremony after the technical presentations. We sincerely appreciate your participation and wish all the presenters a successful technical session ahead. May I now request all participants to kindly proceed to their respective session rooms. Session chairs are also requested to join the assigned sessions. Our technical support team will assist all the participants with the breakout room allocation. Please be patient and accept the invitation to join your breakout rooms. The presenting authors are requested to rename their profiles as session number hyphen paper ID, and the session chairs are requested to rename their profiles as name hyphen session number.
Okay. Thank you. We now move into our technical presentation sessions. Presentation session 1 will be held offline, while presentation sections 2 to 6 will be conducted online. We request all
All the participants present in the main lobby, kindly rename your Zoom profiles as per the format. I've shared the format in the chat as well for your reference. Please rename your profile so that we can smoothly conduct the sessions in your breakout rooms.
Good morning, everyone. Today I am Ranveer Singh from Guru Nanak Dev Engineering College, India, and I am here to present my paper, Beyond Internal AUC, Domain Shift, External Validation Gaps, and Translational Readiness of AI